Welcome to this video. I am Physics and today we are going to be going over elastic strain energy. First of all, what is elastic strain energy? Elastic strain energy is the energy stored in a material when it deforms or changes shape before its elastic limit. This is the formula for elastic strain energy. E equals half F times change in X, where E equals elastic strain energy, F equals force, and change in X equals extension. So how to find elastic strain energy from a force extension graph? In a force extension graph, you will need to calculate the area under the graph to find the elastic strain energy. And you can tell this is true due to the fact that the formula of the elastic strain energy matches with the formula to find the area under the graph on a force extension graph. As you can see that the length is F, and we can see that the base is change in L. And so to find the area, because this is a triangle, we need to do half multiplied by F multiplied by the base, which is change in L. And then this matches the formula over here. So now we go into the GCSE example exam style question where it states, another spring has a spring constant of 250. Calculate the work done in stretching the spring by 0.3 meters. State the units. So over here we can see that there is another formula to calculate the elastic strain energy, where K is the spring constant and X is the extension. And we just need to substitute these values in. So we do a half multiplied by 250 multiplied by 0.3 squared. And when we do that, we get 11.25. And the units for that is, because it is work done, the units for work done is always joules. So now we go into the A-level example exam style question where it states, use the graph to calculate the maximum energy that the wire could store while behaving linearly. So because we need to find the energy stored while behaving linearly, we need to find the place where it stops behaving linearly in the graph. So we can see that it stops at around this point here, which is around 2.6 kilograms. And we can see the extension of it as well, of this point. And that will be around 3.5 times 10 to the power minus 2 meters. So, because this is a mass extension graph, instead of a force extension graph, we need to change the mass into force. So to do that, we do the mass, which is 2.6, which is obtained from the graph, multiplied by 9.81. And when we do that, we get 25.506. And then, to find the area under the graph, we need to multiply by extension and divide it by 2. So we do 25.506 multiplied by 3.5 times 10 to the power minus 2, because it says it here, and don't forget this is really important. And when we do that, we get 0.89271, and because it is a triangle, we divide it by 2. And so when we do that, we get 0.446. In other words, 0.45. And because it doesn't have the units in the answer, you have to write the units. So the units for energy is joules. And there you have it. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.